In section 11.1, we talked about the circumference of a circle, 2 pi r, and then how you can use the formula for circumference to find the length of an arc, because an arc is a portion of a circle. Today, we're going to look at areas of circles, which is a formula that we should know, again, from previous years. Area of a circle is pi r squared. And then we're going to look at areas of sectors, which is a section of the circle, and we'll get into that soon. Just a reminder as far as language, if you want to find exact values for area, as like you did with circumference, we have to leave things in terms of pi. Area is pi times the radius squared. Here, 5 3/4 is 5.75 squared. So if I wanted to give an exact answer for area, I would square 5.75, which is 33.0625, and that would multiply pi. Leave the pi is always written after the number, and also if this radius is in inches, make sure that your units for area are inches squared. If I wanted to find the area to the nearest hundredth, I would then type this into my calculator and I would get 103.87 square inches. That's what area, this is the about equal to symbol. What we're going to focus on is the area of a sector. By definition, a sector of a circle is the region bounded by 2 radii of the circle and their intersected arc. Think of a sector as like a piece of the pie. Here, in this diagram, my sector is this region. It is bounded by 2 radii, PA and PB, and their intersected arc, arc AB. Again, it's like a piece of a pie. So we're going to write a formula that is similar to what we did for the arc length formula, because the area of this sector is a fraction of the area of the whole circle. And that fraction can be found by taking the measure of that minor arc and dividing it by 360. If this was 90 degrees, it would be 90 over 360 is 1/4 of the full circle. If it was 60, 60 over 360 is 1/6 of the full circle, and so on. So I say I take the fraction of the circle times the area of the entire circle. When you want to do arc length, you do fraction times circumference because it's a piece of the circumference. When you find area of a sector, you do the fraction of the circle times the area of the whole circle. This formula can also be written as area of the sector, and there's no abbreviation for that, over the area of the whole circle equals the measure of that sector, measure of the arc, over the measure of the whole circle, which is 360 degrees. So there's 2 different ways we can write it. Here's an example. Find the area of the sector formed by angle ACB. Here's angle ACB. The sector is this shaded region. So I'm going to try to write these answers in exact form whenever possible. The area is the measure of the arc over 360 times the area of the whole circle, pi times 8 squared. 60 over 360 is 1/6 of 64 pi. And I'm just going to reduce this. If I have 64 and 6, they're both divisible by 2. This becomes 3 and 32. I have 32 pi over 3. Go look at my units. The radius was inches, so my area is square inches. I'm going to leave exact form wherever possible. In this problem, it says the area of a circle is 225 pi square inches. Find the radius. We're going to set the area equal to pi r squared. Quick note, when you do problems like this, you have to divide by the pi first. And then I would take the square root of both sides. And again, this is a radius, which is always a positive number. So the positive square root of 225 is 15. The area was in square inches, so the radius is in inches. Here, I'm given the area of a circle is 390 square meters. I want to find the diameter. In this problem, I would have to round because the area is not given in terms of pi. Set the area equal to pi r squared. Divide both sides by pi. And then I would take the square root of that fraction to get the radius. The diameter is 2 times the radius. And when I put that into my calculator, to the nearest hundredth, I get 22.28 meters. Here's a problem where we're given information about the sector. We're told the area of the full circle is 624.36 square meters. That's the area of the whole circle. The area of the sector is 64.17 square meters. I want to find, there's a whole list of things I want to find here, and we're going to round them all to the nearest hundredth. The first thing we're going to find, number 5 here, is the radius of the circle. Well, if we have the area of the circle, that's equal to pi r squared, so I can solve for radius. Divide by pi, and then take the square root of 624.36 over pi. And again, we're using our calculators to do all these calculations, and we get about 14.1 meters. Now I'm going to use that radius to find the circumference. The circumference of the circle is 2 pi r. When I put that all in my calculator, I get approximately 88.58 meters. Now I want to find the measure of arc ST. In order to do that, we need to use the area that was given to us for the sector as well as the area of the circle. The area of a sector, 64.17 square meters, is equal to the measure of the arc over 360 times the area of the whole circle. So I could put pi r squared here, but I also already have a value for that. So I'm going to multiply it by 624.36. And in order to solve this for the measure of the circle, I'm going to multiply by 360 to cancel it out from the division, and I'm going to divide by the 624.36. And when I put all of that into my calculator, I get that the measure of the arc is 37 degrees. Next thing I want is the length of the arc. Well, if I have the measure of the arc and I have the circumference, the length of an arc is the measure of the arc over 360 times the circumference. And again, you could do 2 pi times 14.1, or we already know that is 88.58. And again, we're going to round this, and I get about 9.1 meters. Think about if this is a reasonable answer. The total length around is about 90. 37 over 36 is a little more than 1/10. 1/10 of 90 is 9. This makes sense. For part 9, we want the perimeter of the shaded region. The shaded region here, its perimeter is this arc plus the 2 radii. So I'm going to add 2 times the radius plus the arc length that I just found. And that adds up to about 37.3 meters. Again, be careful with your units. Lengths are always meters, inches, feet. Area is always square inches, square meters, square feet. If I wanted to find the perimeter of the unshaded region, I would find the measure of the rest of this arc, or do the whole circumference minus ST, and then add that to 2 times the radius. I'm going to let you leave that on your own. For today's problems, make sure that you are showing what work you are doing. You need to show the calculations and then give your answers. Give exact answers wherever possible. Round for the problems like this where there's no way to give an exact answer.